All right, for our last example from section 9.3, we are going to do exercise number 10. And what you know by now is, if you've been in this at all, that one of the first things you need to find is the differences. Everything's about the differences. So listed are the heights of fathers and sons, and they want us to use a zero point zero 0.05 significance level to test the claim that there's no difference in those heights between fathers and sons. Well, we know we're going to have to get the differences, so that's what I would suggest to do first. And so for the time's sake, I went ahead and found all the differences. I apologize because I can't get my screen to show all 10 pairings of data, so my advice would be to open up your book to chapter 10 so you can see all 10 pairs. But what I did is I subtracted the father's height and the son's height to come up. And I always do top minus bottom. So I got a -1, then a -2, then a 1, and then a 1. 70 minus 70 is 0. 70 minus 70 is 0. 70 minus 71 is -1. And you can see where all these numbers come from, including the last ones. Well, when I added up all those D's, let me highlight that for a minute. When I added up all those D's, I got a -2. Then I immediately found the D squareds, and I apologize because this one's not so readable, but I squared everything, and those are the numbers that I got, and when I added them all up, they came up to be 31.24. So regardless of what's asked, I'm going to need to know what D bar and S sub D are. So these two numbers help me. D bar is as simple as zero point 0.2 divided by the 10 numbers that were there. The 10 numbers were -1, -2, 1, -1, 0, 0, -1, 4, -1, 8, and 2. And so n is 10, and we get a nice 0.02 out of that. Standard deviation, I just plug in the numbers that are there. The sum of the d squareds was 31.24. Multiply that by 10. Subtract away the sum of the d's squared. Be careful, don't put d bar in here. Make sure you put the sum of the d's. That's what goes in here, not d bar. I've seen it happen to people and it hurts them. Well, let's go to the actual problem. The actual problem is making a claim that there's no difference in the heights. That means on average, with all the fathers and sons, that the difference should be 0. Take a look at where there was no difference in height, the 70 and 70, right? That had a subtraction of 0 coming through. And so that's what they're claiming. So this is a two-tailed test. So the null hypothesis is not, I'm sorry, that's not right. The null hypothesis is also equal to, and the alternative hypothesis is mu d does not equal 0. So this is a two-tailed test. Well, our test statistic is nice. It's d bar minus mu d all over s sub d all over root n. And so what's d bar? Already found it right there. 0.2 mu d, 0. S sub d, 1.86. And root 10, right? N is 10. And so let's see what we get out of that. If we take the 0.2, divide by 1.86, we are going to get 0.0340. Very small number coming out for this test statistic, but that's what it is. And so we know we're going to fail to reject, but let's go watch it happen. We will not have enough information to substantiate that. But let's watch it happen. It's a two-tailed test, right? And our significance level is 0.05, and our degree of freedom is 9. So with the degree of freedom equaling 9, 0.05 in two tails, what do we have? Well, let's look that up. 0.05 in two tails should be the middle column, and it is. 9 degrees of freedom, and we get the value 2.262. That's what's coming out of the table. And negative 2.262. Make sure you show me both the positive and the negative. Well, we're going to fail to reject, just like we knew we were. We are not beyond 2.2 standard deviations away. We're only 0.034 standard deviations. And there is not enough. It is not sufficient data. That's how they word it, to support the claim. right? So we cannot support that claim. We can't even reject the claim. That might have been better since our claim was um, written in the form of a null hypothesis, but we're not going to be able to reject that claim either. So whatever wording there that's been common throughout, right? There is not sufficient evidence to warrant rejection, right? That's what I should put. Because that claim is the same as the null hypothesis, I really need to follow that pattern to warrant rejection of the claim. That the difference in heights is zero, right? So whatever's modeled in the back of the book, that's what we expect you to do as well.